And here we are on another video. So yesterday we went through what do we call the functions that have to do with unions and intersection. So yeah, so we uh, so we learned about the cardinal number of the union of two finite sets. So basically, the cardinal number you're just saying the number of elements in A union B. So this is what we mean by the cardinal number. So don't let it confuse you. So these terms are just so and here's an example. So you have a set of 35 elements and another set of 22 elements. And then you just do this beautiful magic here of, getting the number of intersection elements that are in the intersection of A and B, and then you just do the subtraction, and then that's about it. So this is just for you to get the number of elements in sets like the cardinal. If you recall, the set has a cardinality or an order. So for you to get the order of a set, and this is how you basically obtain it. Now this algorithm here, or this equation here, is very, very, very important. So instead of us having to do this, we could go like, so instead of this, we could go like the number of elements in A union B would equal the number of elements of A plus the number of elements of B minus the number of elements in A intersection B intersecting with B, just like that. So this is how you usually get to do it. I mean, and the reason why I'm saying this, this is the way you would want to do it. So you would so if you do the normal mathematical operations on this, you would end up with, so in this case, so you do subtract the union. So in this case, you would move the union to the other side, and in this case, you would move the intersection to the other side, to the left-hand side, and then you will end up having the number of elements in the left-hand side. So this looks like it's an absolute symbol. So the intersection would equal the number of elements in A plus the number of elements in B minus the union. So it's just a normal mathematical operation we've done there. So that's that. Anyway, so on with this. So we stopped at what we call the symmetric difference. It was a bit confusing at first, but then things started to make sense. I think it would make more sense if we try to create some sort of table of the commutative and associative properties of this union and intersection, as well as the way I actually came to really understand this. So if you try and insert a table of 3 elements and say 4, so commutative property, and we have the associative property. There we go. So the union, we know the union. This is true. This is true. And then the intersection, we know this commutative and associative. So when you go like, say for example, A union B is basically the same as B union A and whatever. And the associative property, if you have brackets, you can move them about however you want. Anyways, so this applies for all. Now this is where we stopped the last time in what we call the symmetric difference. The symmetric difference is given the symbol delta, or this symbol here. I'm not sure what this symbol is called, but this symbol is basically called delta in our case. So symmetric difference, it means that if you have two sets It's basically the elements shared. So it's the elements excluding the union of those two sets. So, sorry, excluding the intersection of those two sets. So all of the elements excluding the shared elements between the sets. So in this case, where you have a set A and set B, you would go like the union of these is 1, 2, 3, 4, 5, and the intersection is basically the number 1. So you will end up with, so if you subtract 1 from the union, you will end up with 2, 3, 4, and 5, and that's how we get the symmetric difference. Now this was fine until this list grew to encompass 3 lists. So when you go 3 lists, it might look like a bit weird. Now if you look at what do you call, I think we have it here somewhere in one of the examples. Where is it? These are the things I have. Yeah, I've also asked this question just to make sure that, because the equation that says A delta B equals A minus B union B minus A. And so I wanted to make sure that I wanted just to make sure that the delta, which is the formula A minus B union B minus, sorry, just 1 second. Let me visit the summary here. We've done the summary, and in the summary we have the delta. Yeah, so this is the equation in the summary. So A delta B equals A minus B union B minus A. So this formula, or this equation here, is the same as, I just wanted to double check my conclusion. I just wanted to make sure that it equates to the union subtracting the intersection. So the union of A and B minus A intersecting of B. And so from the answers is basically yes, both are equivalent, and this is the justification. So it's very clear justification, and I honestly going to take this. So A minus B union B minus A, this is what we've memorized. So you end up with A subtracting B, which is this area, this region here, and then B, you subtract this region here, you will end up with these colored regions. And then if you you'll end up with this, which is basically the same as so it's the union subtracting the intersection, which is the red area here. You would end up with the greens here. So that's that. Now moving on to the next important aspect, which is, if we take a look at, so if we take a look at this, now this is the union. You see, it encompasses all of the sets all together, and then these regions are all colored, which is normal, which is fine. But it would look a bit weird when you sorry. So we had the drawing somewhere. So let's just go with symmetric difference. So with the symmetric difference, if it's 3 sets, you get to see this weird shape here. It's just pretty nice. I mean, it looks visually stunning. I mean, especially if it grows larger. So the reason why this is happening is mathematically. We can easily prove this mathematically. So the way we do it mathematically, say we have 3 sets here, correct? So in these three sets, we're going, and we know that the delta is commutative and associative. So we could take A delta B, get the result, and then that result delta C. So when we do that, the answer would be, if you try to visualize it, the answer would look like this, something like this. And then you see, if you take a look at this shape here, see, this is the excluded portion here, and this is the answer to A delta B. Now if you introduce a third set here, you see it's like the third set is deltaing with the elements excluding this region here. So the numbers that were present here could very possibly be present on the third set. Hence, you see this colored region here. And it's easily to explain this using mathematical operations, and there was this YouTube video that really explains this beautifully. So if you take a look at, we could just so we have three sets here: 1, 3, 2, 4, 1, 2, 3, 4, and then 3, 4, 5, 6, and 2, 4, 6, 7. So let's start with A
sets
delta B.
A and B. These two sets have the difference of A and B.
So yeah, this is A delta B. This is the result. Exclude all the intersecting elements. So in this case, we have 3 and 4. So we'll be left with 1, 2, 5, and 6. Correct? So 1, 2, 5, and 6. And now this, so 1, 2, 5, and 6 delta with 2, 4, 6, and 7. So what you would do is you would exclude all the shared elements. We have 2 and we have 6. So we will be left with 1, 5, and 4, and 7. So let's check that out. So 1, 4, 5, and 7. We're excluding 2 and
Therefore
6.
contain everything except 2 and 6. So
And
the
that's the answer.
symmetric difference of sets A, B, and C consists of 1, 4, 5, and 7.
And that's basically the deal with this. So it was very straightforward, and now understanding it makes perfect sense. So back to our list of notes here. So we know, and now the delta, we know the delta is true for commutative property and associative property. Now if we try to also add the subtraction, or how the way it's presented in literature. So this is neither. So this is false here and false here. So it's neither commutative or associative. Commutative means like A minus B is not the same as B minus A. And then if you have, say, A minus B union C, it's not the same as B minus something union something else. So basically, that is the case. And note something. Symmetric difference may sound like it's subtraction, but it's not. So just keep that in mind. Like in this case, 1, 2, 3, then 1, 4, 5. A minus B is 2 and 3, and B minus A is 4 and 5. So there you go. Commutative is not sufficed here. Commutative property is not sufficed here. So A and B is not the same as B minus A. And if you try to take the symmetric difference, the answer is 2, 3, 4, and 5. So while in this case it's 2 and 3 or 4 and 5, in this case it's it's both cases together, 2, 3, 4, 5. And again, this is the formula on how to do the symmetric difference, and this is how we came about this. So this is out of the way now. So symmetric difference is all clear now for us. Now we should know, we should explore on what to, so we should keep moving, we should proceed forward. And then is commutative. We've answered this. So now I think we've covered pretty much all topics. The number of elements is something we've talked about. Yes, we talked about the number of elements here, and that's out of the way. De Morgan law is out of the way. Distributive and associative for the union, intersection and union. Distributive laws. So distributive laws are somewhat different here than the commutative and associative rules. So I think that's about it for now. We've done a pretty good job so far with this set. I think we've covered a really good chunk here. And then if we try to visit the book again, we basically covered, so this is the symmetric difference. We've covered basically everything we need to know about. Yeah, we've also explored disjoint sets in which the intersection is an empty list. And yeah, that's awesome. So next topic, so this was sets. The next topic is mappings. So mappings would be next on the charts. So next video is going to be all about mappings. I'm not sure what it is about, but from the looks of it, it looks like it utilizes sets, that's for sure. There are commutative properties as well to it, identity and all that stuff. Awesome. So yeah, see you in the next video then.